Thank you. So today we're presenting zero-touch end-user service update mechanisms via an open orchestration platform. This has been a joint work from me. I'm the presenter, Vasilios Katopodis, Labros Papadopoulos, Alexandros Valandasis, and Georgios Katsikas. He's in the call now. We've all worked through this. So let me start. Sorry about that. Okay. So we see that we have a service that we want to deploy somewhere in a cluster or a hub or something. So a service lifecycle undergoes many stages. Let's say a bit its lifespan. First, we have to design the service and make it available in a service catalog or something else. Then we have to submit a service order ordering this specific service. And then we have the runtime management. As soon as the service is available, maybe go ahead and make an update or something, monitor its life cycle, etc. So we have an orchestration platform that facilitates LCM through APIs tailored to each stage. Now let's see our objective here. Somebody has like a service here, a service graph already designed. So it goes through all this life cycle, and at the end, when the service is deployed and it's manageable, we expose a rich set of runtime service characteristics to facilitate service reconfiguration. We're going to see that in action in a while. And leverage standardized APIs to promote interoperability. We're going to see this, all these layers in a while. So the relevance here is that somebody orders a service via the service inventory, then it goes live, and via suitable service telemetry, it exposes data back to AI analytics, user-driven decision engines, and yeah, so there is an interaction. There might be like heavy traffic or something else, like a cyber attack or something. So once again, somebody interacts via the service inventory and changes the service, its exposure, etc. So the service inventory API is responsible to close this loop and makes this like interaction. Now, let's see our scenarios. So one scenario is real-time updates for service scaling. There might be like low traffic or heavy traffic, and we might want to change that dynamically according to that. So there are real-time updates for service security in case like of a security patch rollout. Like if we have a cyber attack or something, we might be able to deploy a new version of the service that cuts this malicious traffic. And also there are real-time updates for service relocation. We might want to move our service to a new cluster or somewhere else, and yeah, there's like a need for that, and the API can handle and do that. Now, let's see our setup and some assumptions that we take before we submit the service order and manage the service via the API. So in order to do that, we need an input service. We need to handle it through a multi-domain service orchestrator. manage the various domains that we have. Underneath, there is a domain and service and resource orchestrator. Lower layer is a clusters manager and the scheduler. And on the very end, it's a managed infrastructure. So in our case, Maestro that has been designed and developed via the TM Forum standards works as a multi-domain service orchestrator. Underneath, there might be a domain service and resource orchestrator. Like in this case, it's OpenSlice. Once again, there is a clusters manager and scheduler and the managed infrastructure. So one of the assumptions that we make is that the OCM hub is pre-installed and it has 3 managed clusters underneath which are registered to the hub, 2 Kubernetes and 1 OpenShift. OpenSlice exposes the OCM hub as a service. There's an available service specification that one can order the specific hub. Maestro has already paired with OpenSlice. This is one of the functionalities of Maestro that can pair with various OpenSlices. Like OpenSlice, we can think of it as a point of presence in various domains. So it can connect and interact with all of these. In our case, of course, it's one, but Maestro can do that with multiple domains. And Maestro catalog contains this OCM and also end user specifications that are used by the user in order to deploy the service. So at the very end, a user should design and package the application in a Helm chart and store it in a registry, and the registry credentials should be shared with Maestro. This is done in a secure way, so there will be no data breach or something. Okay, let's go to service and resource provisioning. What we will do here is the resource allocation. We will order the OCM hub service from the Maestro service catalog. Maestro will transfer the service order to OpenSlice. OpenSlice will retrieve and expose the OCM hub's kubeconfig. The order will be marked as completed, and Maestro will mark the corresponding service order as well as completed. And what we can do later on at a later stage is that we can order via Maestro our already packaged service to be deployed in this specific Kubernetes. All that the user will do is that provide the Kubernetes service ID key in the service order, and that's it. Maestro will handle the rest of it. So Maestro will connect to the OCM hub using the already mentioned kubeconfig. And it will deploy the service package on the OCM hub. And as soon as this is done, OCM will schedule the service according to what the user has provided. In our demo, we will initially deploy all the service components in one Kubernetes. And then Maestro will mark the end user service as completed. So pretty much that's it. The service will be available in the UI, and then according to our needs, we can perform any updates. We will see that in a while. So at this point, let me present a few demos that we have done for up to this point, and you can watch that. All the things that I said already, you can watch them in the video. Okay. Let me put my VLC here. Okay, so this is the initial setup. All right. Now we will switch and show the order of the Kubernetes, the OCM hub, to be specific. All right, now let's switch to the third video and we will see how we will order the end user service. Okay, now let's switch again to the presentation. We've reached the step that our service is available. It was deployed on the first cluster. Now, okay. Now we'll go to scenario number one, real-time updates for service scaling. So let's see. In this example, we will choose the replicas of the component PHP myadmin to be updated to 2. How we will do that? Maestro exposes service configuration knobs via the portal, and the user goes ahead and modifies the specific characteristic, like the number of replicas or CPU. We will do the replicas in this presentation. So the update is dispatched to the Maestro backend via the portal, and Maestro applies the updated manifest to the OCM hub, and then we expect to see the update in the managed cluster. So a replica instance will appear after all the update is successful. Now, let's see the next demo. All right. Now let's go to the scenario 2, real-time updates for service security. What we have in this scenario, we emulate a potential attack to the service from an external entity. Increasing number of requests are issued to a certain component of the service. And then the service designer creates a security patch to fortify the service using a network policy. So Maestro exposes service configuration knobs via the portal, as we mentioned already. What will the user do? It will go to the service artifact version characteristic, and the user will bump up the service version, and a rollout of a new release will be on the fly. So after the user saves the change on the portal, the update is dispatched to the Maestro backend. Maestro applies the updated chart to the OCM hub, and OCM hub requests service rollout from the managed cluster, and then the network policy is applied and filters traffic. Pretty much that's it. So let's go and see our next demo. All right, let's move ahead and go to the third scenario, real-time updates for service relocation. So the service designer in this scenario wants to move two of the service components to another cluster. Once again, we have the characteristics exposed via the portal in order to do that. What we will do is that we will modify the cluster metadata accordingly. One of the service will remain, I'm sorry about that. So one of the services will remain to the Kubernetes, and two of the components will move to the OpenShift component. So Maestro applies the updated chart to the OCM hub after the user saves the service in the portal once again, and OCM hub will request the service relocation from the managed cluster, and the two service components are scheduled on the OpenShift cluster. So let's move to our last demo. So I will present you the team that has worked on all these components that you've seen in these demos. Vasilios Katopodis, Senior Software Engineer, Labros Papadopoulos, Software Engineer, Alexandros Valadassis, Technical Management and PM, Vasilios Harlaftis, Software Engineer, Pantelis Maleka, Software Engineer, Georgios Katsikas, he's with us in the call. He's NSS Technical Leader and PM, and Nikos Psaromanolakis, who is in the Technical Management and PM. Top left, it's me. Now let's see our open source activities. Maestro, which has been presented in the demos, has been developed by Ubitech. OpenSlice, it's from the University of Patras and PNet. Open cluster management, it has been developed by Red Hat. And the projects behind this work are across NP2 code. So these are the acknowledgements. We have this horizon across projects with grant agreement number, etc. And the programming platform for intelligent collaborative deployments over heterogeneous edge IoT environments, P2 code under this grant. Thank you. Thank you very much. Let me stop the share. Hello.
Yes. Just hello. Thank you very much for the nice presentation. Just wanted to mention. I saw that you were discussing and explaining briefly Maestro. Is this planned for open source or it's available?
It's not available yet, but as far as I know, it's in our very like it's in our plans to do it in the very near future.
Okay, thank you very much.